Welcome to this video on random forests in data mining. Today, we will explore how this ensemble learning technique improves predictions and reduces overfitting. Let's begin by discussing the outline for this video. First, we will understand what random forests are and how they work. Then, we will learn the steps involved in building a random forest. Next, we will explore how to interpret predictions made by random forests. Finally, we will implement a random forest model using Python and scikit-learn. Random forests are collections of decision trees, built using random subsets of data and features. Predictions are made by aggregating results from all trees, such as majority votes for classification or averages for regression. By creating low correlation trees, random forests effectively reduce overfitting while maintaining robust predictions. Now let's look at the steps to build a random forest. First, generate multiple bootstrap samples from the dataset. Then, build a decision tree for each sample, using random subsets of features at each split. Aggregate predictions across all trees to make final decisions. Hyperparameters like the number of trees and maximum depth can be tuned for better performance. Python's scikit-learn library makes implementing random forests straightforward. The code snippet provided shows how to initialize and train a random forest classifier. It splits the dataset into training and testing sets, fits the model, and evaluates its accuracy. This makes random forest implementation accessible for various predictive tasks. Interpreting random forests involves analyzing feature importance scores, which indicate the relative contribution of each feature to the predictions. Individual decision trees can also be analyzed for specific predictions. Random forests provide robust and reliable results by combining multiple weak learners. Let's discuss the advantages and limitations of random forests. Advantages include reduced overfitting compared to single decision trees, effective handling of large datasets, and feature importance scores for model interpretability. However, they can be computationally intensive for large datasets and less interpretable than simpler models. Additionally, they require hyperparameter tuning for optimal performance. To summarize, random forests combine decision trees to deliver robust predictions. Bagging and random feature selection reduce overfitting while enhancing performance. Python's scikit-learn library simplifies their implementation and evaluation. Feature importance scores help interpret models effectively. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.